A warm good afternoon. So first of all, I would like to thank the management for providing this opportunity to deliver a lecture on Introduction to Machine Learning. So about me, I'm Ragavi and I'm pursuing my PhD as well as I'm an assistant professor in the Department of Information Technology, VNR VJEC. And my areas of interest includes like machine learning and optimization. And my email ID. So, data science, machine learning, deep learning, AI. So, this four words we are come acrossing this in our day-to-day life, and these four words I could say like it has been in recent trends. So, I'll explain like what is meant by data science, what is machine learning, DL, and artificial intelligence. So, the outer ring like artificial intelligence. It is like creating the smart machine to mimic human behavior. So, what it means is like process where some kind of application is being developed without any human intervention in such a way that it perform the human task. All right. So, for example, I could say like Netflix. So, if we watch some movie, if I say some horror movie, and if I watch some horror movie for the day, the next day I'll be getting some recommendations based on the previous data. So, Netflix, Amazon, and even I could say like Tesla car. So, each and everything is been using this AI application. So, that application has been developed in such a way like it is behaving like a human. I could say like it mimics the human behavior. So now what is meant by machine learning? So if artificial intelligence is human behavior, it is mimicking, then what is meant by machine learning? So machine learning, it is a subset of AI, I could say. See, for example, this is my AI I call, then this particular I call it as a machine ML. So this machine learning, it is a subset of AI and where a model is being built based upon the data I provide into it. And based upon the data that has been provided, that particular model is being trained with the data and some prediction is being made. So that is what in a definition way we have learned so far. Yes. So artificial intelligence, it is like mimicking human behavior. And if it comes to a machine learning, we will say like some model will be trained with some data and some prediction will be made out. So that's what we have covered so far. And in short, I could say like AI, it thinks like a human, whereas machine learning, it learns from the past data and it will make some predictions out of it. So the next terminology like deep learning, it is a subset of the ML where it is mainly used for solving some complex problems. So in DL we have come across to this ANN. So everyone will be aware of this term, artificial neural network. So it is very similar to our human brain. So that particular learning methodology is being designed for solving some complex problems. So as of now, this artificial intelligence, this machine learning and deep learning, I know like it has been interconnected with each other, but what is meant by this data science? So data science, it is a subset of AI I call. So where it includes like statistics or some scientific methods and where can I find the insight about the data? So that we calling it as the data science. So today I'll cover about this machine learning in an overall view. Like according to Herbert Alexander Simon, he calls like learning. What he defines learning as any process by which the system improves the performance from the experience. So in the similar way, he coins the machine learning with it is a set of computer program that has been designed by the user that automatically improves the performance based upon the experience. So with this, why is this machine learning needed? So as we know, like today we are using this terminology in all the areas of research, but why this machine learning is actually needed? Because it is the ability, machine learning is the ability to mimic human as well as replace certain monotonous tasks that requires high intelligence power. And also that machine learning can develop system where human intervention is high, that is, that are very difficult, and sometimes we feel that it is very expensive to do. In that cases, we can use this machine learning where it simplifies our process completely, and also develop the system that can easily adapt and customize themselves to the individual user. So based upon the individual users, the learning algorithm can be adapted and also it can be customized. So the applications of ML, I could say, like from starting from the neural network and electronic, automation, cyber, analytics. So everywhere we could see this ML is being applied. So previously I put a word like machine learning, some data has been taken and that data has been trained and we get predictions out of it. Now what is the data all about? So when we talk about this data, we have three types in it. One is called as the structured data. So what is structured data? So it follows some predefined format. Yes, so in machine learning we call it as the word data set. So if I take this is as my data set and it follows some predefined format. Yes, so that is called as the structured data. And unstructured data without any formal structure, we call it as the unstructured data, and examples can be text, images and so on. And semi-structured is like it has some organizational property but lacks some rigid structure. So example I could say like XML. So the next one, after discussing what is the data, so now we understood like what kind of data has been used in the machine learning model and what is that machine learning model, what is the types in machine learning model is supervised learning, unsupervised learning and reinforcement learning. So what is the supervised learning? So learning from the labeled data, we call it as the supervised learning. So for this example, I could say like classification and regression are the examples under the supervised learning. And what is then unsupervised? If supervised includes labeled data, so what can be the unsupervised learning can be? So no labeled data, that is unlabeled data. So with this unlabeled data, the model will not be able to label it, right? So it will find the hidden pattern from the unlabeled data because we don't have any label out of it. So it will find the hidden pattern from it. And then what is about this reinforcement learning? So I call this reinforcement learning, it is a trial and error method, where it learns from the user and it takes out the feedback. Either that feedback can be a positive or a negative, and based on that feedback it will work on and it will produce a prediction. That is called as the reinforcement learning. So today I'll cover about supervised learning. So as a researcher, so I have been utilizing this heart disease data set for my research. So the similar data set is being taken for today. So age, BP and HD. HD I call it as the heart disease. So what we call the 10, 120 and absence. So this particular row is called as the samples. So what we call this row in a dataset is called as the samples. And then what is this column is all about features, feature and the feature values. So here I could see I have three features. So one is I have age, second one is I have BP, that is my blood pressure, and third one is heart disease. So if you could see, this age is a continuous value because it starts at 10 and it goes on. Yes, so age is a continuous value and BP is also a continuous value. So with this age and BP, I'm going to predict whether that particular sample, so what do you mean by sample here? Patient. For example, I call it as a patient number 1. Alright, so with the age of 10 and with the BP of 120 value, that particular sample is free from heart disease. That's what that sample indicates. Yes. So similarly, 14, age of 14 and BP as 120, I could say the heart disease is absence. So what it mean? Age of 30 and BP at 130 and my heart disease is absence. So similarly, we have some n number of data. So this age, this heart disease is totally depends upon this age and BP as a factor. Yes, so how can I predict this heart disease? Through my age and BP. So if I say age is low age and if my BP is normal, then that particular sample is free from heart disease. Yes, so now the algorithm Now, I take this model. So what this model? It can be like any supervised model. So we have so many models is, under the supervised learning. So any algorithm can be taken here, and this data has been fed into that model as an input. So what is the data here? So this data, yes, so this age, BP and heart disease. So this data set is been given as an input to the model, and now I'm making this model train with this particular data set. Yes, so at the outcome of this, my model, so and so, any model if I take, I can take any model. Now, this model, particular model will be trained with this particular data set. Okay, and some predictions will be made out of it. And how to check whether this works fine or not? I take one test case. Alright, in that test case, I give my age as 11 and my BP as 150. What is the prediction I get in turn? Alright, so the ultimate point I would like to say is, I'm training this data set in such a way this particular model will be learning it, and when similar data arrives into that model, that particular model should be in a position to predict. Yes, so that is called as the supervised learning. So here we are using the labels. What is called as a label for me here? So heart disease is a label. I'm feeding this model both with my input, age, BP as my input, and heart disease as the target variable, that is my output. So with this, I'm training my model. After this training is been done, I'm giving some other use case as an example to check whether that particular model has learned from the data and whether the prediction is made is right or wrong. Yes, so this is called as the supervised learning. So all the input and the output is being given to that particular model for training, and once the training is being done, we are going to check it out. That is called as the supervised learning. And so the outcome of the supervised, like I can say, like one is the classification problem and another one is the regression problem. So here, this I can say it as a classification problem. See, if you check out, this is my target variable. My target variable is of course the heart disease, and I say whether the particular sample has the heart disease or it don't have the heart disease. That's what my target variable is about. So this falls under binary classification problem. So binary classification problem is if the target variable have only two classes. Yes, either S class or the no class. And what about this multi-class? If the target variable has more than two class, we call it as the multi-class problem. Alright, and what about this regression? See, so far we are concerned about like finite values. If my outcome variable, if my target variable is in a continuous value, then we call it as the regression problem. Alright, so for classification, I can take a very best example of prediction of the heart disease. So this is the heart disease data set which I have taken here, for example, age, BP and heart disease. And for this regression, to help you understand what is meant by regression and what is the continuous value, I can take an example. See, I have a data set and I have the features, area, and this area has been measured with square feet. And another feature I have number of bedrooms. And the next one I have price. Alright, so I have area, bedroom and the price. So these three features I have taken. So square feet, for example, I'm giving it as 1200 square feet and bedroom size as 3. My price is 12 lakhs or something, and my square feet is 1500. If I say bedroom size as 4, and my price is of course some 20 lakhs, and this data set values, it goes on. Yes, so this price is my target variable, and if we take that price, we have the values in a continuous values. Yes, so we could not plot it. So if we have that binary class, we can either stick to one class, either presence class or absence class, or based upon the target value. But if it is your continuous values, you cannot put into this class or that class. Yes, so that problem we call it as the regression. So the supporting algorithms for classification problems can be logistic regression, KNN, support vector machine, decision trees and random forest. And for the regression algorithms also we have linear regression and the ridge and lasso. So now I'll talk about unsupervised learning. So what is meant by unsupervised learning? See, here I don't have any labels to classify. Yes, so in the previous example, I have a feature called heart disease. So that heart disease is my outcome variable. So all my inputs and the corresponding target variable is being trained to that model. But here I am totally unaware of the labeled data. So I call the target variable as the label. So label is nothing but my target variable. So here, unsupervised learning, if we take, we don't have this target variable. Then how come the model will try to fit whether it belongs to so-and-so class? So we have two options. One is called clustering and another one is called as the dimensionality reduction. So what does mean by clustering? Because I don't have any specific classes, what I'll do, I'll put in some groups. Yes, for example, I'll make this as age, and based on that age I'm going to predict the weight. All right, so since I don't have any labels here, what I'll do, I'll put in some clusters. Yes, I'll form some cluster, and whenever the age, whenever some new test case arrives, it will either fit in this particular cluster or this particular case or this particular case or this particular case, and it goes on. Yes, so since we don't have that label, so what we are doing is based upon the range we have. All right, based upon the range we have, we are fitting the new values into some cluster. So that is the clustering concept. And what is meant by dimensionality reduction? Dimensionality reduction is actually reducing the features in such a way that we should not lose the important feature. Yes, so whatever feature that is repeated, all right, so that features can be ruled out from the data set. For example, weight, height, and calculating the BMI. So why should I need this weight, height and BMI as a separate feature? Rather, I can ignore either BMI or I can ignore weight and height because both conveys the same. Yes, so this is called as the reduction. We are going to reduce the feature set in such a way, but you don't lose any information. All right, so that is called as the dimensionality reduction. And today, I'll explain this with the example data set, and that example data set I have taken is like iris data set, which is a very familiar data set where all the researchers will be handling over this iris data set at their initial step. So features in this iris data set, I have sepal length, sepal width, petal length and petal width. So what we mean by a feature is the particular column is that considered as the features. Yes, and my target class is like 3 classifications. So we have learned, like I come to know this iris data set is a classification and it is a multi-class variable. How did I find it as a multi-class variable? Because I have 3 classes in it. So that particular sample, if I take, yes, so with some sepal length, with some sepal width, with some petal length, with some petal width, and what is that particular class it belongs to, whether it belongs to Setosa or versicolor or Virginica. Yes, so that is my target class, and the total samples that is being considered is 150. All right, so now I'll show like how we'll work this. So now I'll show this how it works in our like how we take that particular data set, how this data set is being taken and how that prediction is being made. All right. So if we are at the base level of learning, then it is better to use this collab, and this collab, it is like a source, like basic source where you can run that each and every code. Like we have cell wise concept, so each and every cell we can run it and we can learn it. So I have chosen this collab as the platform here, and you can even use Jupyter, PyCharm, and many platforms are there. All right, so import pandas as PD, and we have in one more advantage when using Python is all this library when we import into our coding, it will be very ease of use. Yes, we need not type for each and everything, we need not type, rather just import the libraries into our code. All right, so pandas as PD. And loading the data set. So what is the command for loading the data set is df is any variable pd pandas dot read csv. So that I have named that data set as iris dot csv. So the next one is I'm going to print it. I'll show it visually. Yes, so this is the way I have read it, and if you click on the cell, it will run. So here we can see like 150 rows are there with 5 columns. So 150 rows, we are calling it as the samples, and 5 columns. Yes, 5 features we have: sepal length, sepal width, petal length, petal width, and class variable. Yes, so this is the way we can load the data set and we can run it. And the next one is, see, df dot head. So what is this df dot head? It will do is, it will list out the data set in a way like you can see the samples in see, df dot head, it will show only 5 by default, or if you mention here as 10, it will show the first 10 samples. Alright, so df dot head of that particular value. So if I want to see, if I my condition is I want to see only the first 3 columns of the data set. So if I give as df dot head of 3, only the first 3 columns, first 3 samples will be visible to us. All right. And what is this df.info? So df.info, it gives an overall information about the data set that we have taken for the analysis. See, so we have the sepal length and the number of samples supporting is 150 and the data type, what it means about. Yes. And here I'll show to check whether, see, real data set, if we take any real time data set, it will be with some null values. Yes, some values will be missing. So where we need to apply some pre-processing technique in overcoming that null values. So to find out the null values in particular data set, we can use this is null. So it will give you a list of null values that is being present feature wise. See, sepal length, they don't have any null values. So this data set is free from null values, which means all the samples are with values. Yes, no missing value is there. And df.describe. So what is this describe? Describe, it lists out the statistics of that particular data set. All right. So I have taken this iris data set, and if I put as describe, it will be showing, see, count. So what does this count variable mean? So total number of samples that has been present in the data set. And mean value is each and every feature that has been present in the data set. For that, the mean value will be calculated. So mean and standard deviation. And what is this minimum value? Minimum value is the minimal value that particular sepal length feature has. So 4.3 is the minimal value it has, and the maximal value we have is 7.9. And what about this 25%, 50% and 75% is for the finding out the outlier. So we have the interquartile range. So these things will be, I'll be covering in the next lectures. So the next one, describe.transpose, we are just going to transpose this particular, which we get in the previous describe. So if I use this transpose, all your rows and columns will be interchanged and you will be getting in the structure. And now to identify the target column. Alright, so what is my target variable I have taken? So my target variable I have taken is, see, target column is equal to the last one. So that is my target column I have taken, and I have printed and visualized how my target variable looks alike. So if I don't want to see this, see, I have used here as 51, and if I give here as 150, see, because 150 is my overall samples I know. So if I give it as 150, so all my 150 values you can see in your cells. Yes, so this is why, so 150 samples I have, and all is 150 along with the target class will be visualized here. And this is particular code is to check the unique target value. So I said the word before, like this particular iris data set is a multi-class with 3 options like Setosa. Yes, 3 options we have, 3 classes we have. And to check that, how many classes is being present in the target. All right. So for that, we have this target class. See, if you run it, see, unique classes, I have 0, 1, 2, 3. So what is the 0, 1, 2, 3 is the value of my target class. So 0 is for Setosa and 1 is for Virginica. Like that, I have 3 classes and number of classes is 3. So here I say it is a multi-class classification problem. All right, the next one. So this is the way, like I'm going to import this data set into my collab. So we have like we have some file option here. You have to import your data set here and then you have to run. But suppose if you have an online data set, how can you do it? Yes, so this is the same one I have used, but using my online. See, load the iris data set in an online way, and it is again I'm going to print everything that has been done before. All right. Yes. So the next one, I want to see, and now I have visualized my target class. Like I have 3 classes in my target. And to visualize that, we have so many libraries that supports the visualization part, like Matplotlib. You can find out the visualization. See, so I have this 3 classes, Setosa, Versicolor and Virginica, and along with it, so x-axis represents my classes and y-axis represents the count. So out of that 150 samples, 50 samples it belong to Setosa, and 50 samples belong to Versicolor, and 50 samples belongs to Virginica. So point is like you have histogram also, if you want to view it in the histogram. So everything has been supported in this Python. Yes, and now I am going to run this. So split into training and testing split. What is that split into train and test? So previously we have learned, like supervised, it will be training the model with some training data set, and to test that whether it works fine, we will be giving one test sample and we'll be checking whether that prediction has been done by that model or not. Yes, so for that I'm going to split in such a way like 0.2% has been given for test size and 0.8 has been defined for the training data set. So training data. All right. So now I have chosen logistic regression. So I am going to train this model with logistic regression. So training here, training and testing will be done, right? So that training part will be taken, and that will be, and that is being trained with the logistic regression classifier. And now I'm going to make predictions of it. See, I'm going to give one test data and check whether the model is finding right with my test sample or not. So I'm going to give my test data and I'm going to check it out, and the final evaluation is being done here. So to find out the accuracy, we have some function supported. So accuracy score of that y test and the y prediction that is done, and classification report also you can see, and the confusion matrix. So the ultimate outcome of any particular model we'll be evaluating with this confusion matrix. So that confusion matrix also you can take using this function confusion matrix. All right. So since I know it is a 3-classed target variable, so I am getting the confusion matrix in this way. And see, so this is the class-wise precision recall F1 score. So we have this performance metrics in ML, which includes accuracy, precision, recall, and so on. Yes, so class-wise we can see that precision and so on. So this is the weighted average. So today I have taken one particular data set, iris data set, and I have taken this logistic regression for prediction. Yes, so similarly we can take any data set and this process can be continued. So thank you for this opportunity.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.